the University of Oklahoma focused on creating a waste fuels gasifier. Commercial wood chips are expensive, and trees don't grow that fast, but switchgrass is plentiful. There is also an abundance of red cedar, which, as I understand, harms the environment. Apparently, it was about the dry leaves of this cedar. That's why this gasifier is designed for loose layer fuels, such as grass. Maybe you've seen dry leaves lying around thujas and junipers on the ground. Most likely that's this kind of waste. It took a long time to create such a gasifier. The developers relied on a whole series of other scientists' works to create a special vortex reactor. By the way, they tested it, also successfully, on sawdust and grass with briquette household garbage. Let's look at the gasifier more closely. I left links to its description below the video for those who want to learn more. The secret of this gasifier is that its reactor for grass is a perforated cylinder. Now I will tell you how it is made. A bit of theory to understand why the developers made it that way. If grass is put into Embert's downdraft biomass gasifier, the powerful flow from the tires will burn out a layer of grass around it in seconds and form a dome-like void. Even shaking the gasifier so that the dome collapses will not help much. A powerful airstream from the tires will raise the temperature to 1,100 degrees. Accordingly, the grass, which ash melts already at about 600 or 800 degrees, depending on the type of grass, will turn into vitrified lumps and prevent the fuel from flowing in. It is necessary not to increase the temperature too much on the one hand, and to eliminate the problem of domes and voids inside the fuel layer during operation on the other. How did the Americans do that? Let's look at the screen. The problem of hangups and formation of voids inside the fuel layer was solved by an agitator rotating at a speed of 8 revolutions per minute. The agitator was made from 304 grade stainless steel pipe. Its outer diameter was 25 millimeters. The gearbox was fit for 418.9 Newton meters. It could rotate the agitator both clockwise and counterclockwise. The diameter of the gasifier was 0.6 meters, and its height was 2.3 meters. The combustion zone was a hollow perforated tube with a 5 mm thick wall, in which many 6.35 millimeters holes were drilled. The distance between hole centers was 9.52 millimeters. It turned out that the area of the holes made 40% of the area of the pipe, if I calculated correctly. This perforated pipe was made of the stainless steel grade 310. The other parts were made of the stainless steel grade 304. The air was fed around this tube tangentially to the outer edge of the pipe. In the patent, it is drawn that the air inlet tube is at the top, mark 138 in the picture, and a kind of vortex is obtained around the perforated pipe. When they built such a 100 kg per hour station, the air was supplied from 4 sides if I'm not mistaken, and if these are pipes located at an angle above the inscription gasifier. It's hard to say exactly, because the authors didn't bother to describe their appliance very accurately, but did so superficially. I have to guess, before starting the gasifier, the perforated pipe was heated up to 600 degrees by a propane burner through hole number 136, according to the scheme. When fuel pyrolysis started and combustible pyrolysis gas came out, the air was turned on, and this gas, released through the holes of the perforated tube, began to burn, swirled evenly, enveloping the perforated pipe with flame. The pipe and the fuel in it were heated. Such gas is slightly more caloric than gas from an ordinary gasifier. Its combustion temperature is about 1,300 degrees. If you look at the figure of the vortex air supply angle, the perforated pipe is likely to be about 500 millimeters in diameter with a full diameter of 600 millimeters. This way 2 birds were killed with 1 stone. Tar was burned off. Its amount could reach up to 200 grams per 1 kilogram of wood during half coking, and the grass turned into semi-coke, which was already converted into generator gas while going down the throat, located below the perforated pipe. The vortex allowed to lengthen the tar burning and water decomposition stretch. Spiraling down into the throat, it carried the water vapors, which were already decomposing on the semi-coke, having traveled a long way to the grate. The temperature was not raised too much, so as not to vitrify the ash. It was kept around 800 degrees. Tar was about 6 grams per 1 cubic meter of gas. Efficiency was like that of Embert's gasifiers, about 66% for cold gas. But the unit could run on grass and sawdust. Later, one more research was made where up to 40% of pelleted garbage was added to grass. And the gasifier worked well. Here, in the three-dimensional drawing, I am showing a commercially built mobile station gasifier for 100 kilograms of grass per hour. Links to the puzzling description of the appliance are below the video. See you soon.